just brief you about the history of Intel processor. I think everyone is aware about the role of or the contribution of Intel in processor market. So due to their presence in the market, these Intel microprocessors are basically studied. And for computer engineers specifically, we have this particular topic. So as a history point, I will just brief you about the first microprocessor, which was introduced by Intel 4004, right? And this was the first microprocessor in which all CPU components were on a single chip. And this microprocessor is 4-bit. Now, if you remember, we discussed about the various components of a microprocessor, right, earlier when we discussed about the topic, last unit topic in DLD. I think all of you must be remember about the resistors which are expected, then ALU which is expected, then the interconnections which is there, and then addition to that there is a control logic which is there, right? So these four blocks were there, right, in the diagram that we discussed. So main components are the ALU, resistors, and the control logic. All right. So all those components are basically fabricated on a single chip, right? When with the 4004, and it is a 4-bit microprocessor. Now, can anyone brief me about why exactly the particular processor is called as 4-bit or 8-bit or 16-bit microprocessor? Anyone can answer. What is the reason why a particular processor is called as 4-bit or 8-bit or 16-bit or 32-bit and distant 64-bit microprocessor? Anyone can unmute and give answer. And I'm not expecting like I will call a particular name and then yeah. So those who are aware that can answer. So what is the reason why a particular processor is called as 4-bit or 8-bit processor?
Sir, I think it is because the processors are capable of carrying out operations on that many bits of data at a time.
Very correct. This is the first condition which is mandatory, right? So when we are talking about the processing data, so that processing happens in the ALU, right? So ALU capacity to handle the maximum number of bits as a single operand. So 4-bit, when we say, so we can perform 4-bit operations, right? Operations, various arithmetic operations, logical operations on 4-bit operands. So like that, we have 8-bit micro 8, and these are basically designed for very specific applications. These were designed for very specific applications. Then later on, they introduced 8080. This is the Intel's first general purpose microprocessor. And later on it is upgraded to 8085 microprocessor, right? So it is in 1974. So this is just a history part that we are talking about. So this is just summary of all processors which were actually manufactured, and we are talking till Pentium and few code. So next one, 8080, it is the first general purpose microprocessor. Now when we talk about general purpose, then in PCs, personal computers, these microprocessors were used. So it is 8-bit microprocessor. As we discussed that 8-bit means its ALU can handle 8-bit size operand, right? Addition to this reason, there are a few more reasons. Second one is the internal registers, general purpose registers which are there, those will be of 8-bit, right? Additionally, the internal bus to carry data will be of 8-bit, and optionally external data bus, right? External data bus to transfer data between external components and the processor. Whatever external data bus is there, its size is 8-bit. So generally, the last parameter is optional, because there are processors in which we will find that the external data bus is much larger than whatever the processor type is, right? So these are the 4 reasons when we categorize particular processor, right? So after this, 8085 was also there. 8086 is one more microprocessor which is introduced, which is 5 mega operates with 5 megahertz frequency and manufactured with 29,000 transistors, and it is much more powerful. This is the processor in which you can see the segmentation feature was introduced, right, and which is later on extended, or it is used with the whatever recent microprocessors. But the first concept of memory segmentation was introduced with this 8086. It is a 16-bit processor which is having instruction cache, right? Then prefetch, which is this instruction cache is the first introduced 8086 in the 8086, right? So the few instructions can be prefetched, and then after this 8088 is another microprocessor, right, which is basically having similar features of like 8086, but only difference is the external bus which is there, it is 8-bit. So here you can see 8086 is basically a 16-bit microprocessor which is having 16-bit external bus, and its version 8088, it is another version, or say it's version of 8086, but it is with 8-bit microprocessor, and it was used with IBM PC. This basically earlier 8080 was used with the IBM PCs, and in that 8-bit external bus was there. So to make use of advanced features of 8086 with the existing hardware, they have simply modified the external data bus. So that is the main reason. Then you can see 286 is there. So addressable memory space is increased, right? 16 megabytes memory addressable, and which is up to 1 megabyte bits we can extend. So here, after that, 80386 is the most popular microprocessor which was introduced, and as we discussed yesterday, 32-bit microprocessor it is. Then it supports multitasking. Then protection was enabled, right? So virtual mode is enabled in that. So many things are there. Then it comes to 80486. So this is one of the interesting and important microprocessor in which cache was introduced. One of the powerful cache. So here the instruction and data cache was introduced, right? So which is basically used for instruction pipelining. And then additionally, you can see the built-in math coprocessor is introduced with 486. So here you can put remark over here. 486 is the first microprocessor in which the on-chip coprocessor is introduced in the form of floating point unit, FPU, right? FPU, in the form of FPU. So here, this FPU is basically having same architecture like your coprocessors. So earlier to 486 with up to 80386, to handle the floating point numbers or the real numbers, coprocessor was used. So this is the additional processor which is available, which was available on the motherboard. But from 486 onwards, coprocessor is removed from the motherboard, and that is fabricated on chip itself, right? Then it comes to the Pentium, right? So Pentium is a superscalar architecture. It is it executes multiple instructions parallelly, right? Then Pentium Pro is there. So again, whatever the after Pentium, you can see the so many advancements happen with the Intel microprocessors. So with the Pentium Pro, you can see increased superscalar organization. Superscalar is basically the feature, right? You can explore this particular term in which parallel execution of instruction is supported, right? So here, whenever you think of multitasking, in multitasking, I will elaborate more about it in 386 topic. But when you talk about the superscalar architecture, then practically two instructions are executed at simultaneously. Right, in multitasking environment till 486, right, this parallel execution was not possible. So with the superscalar architecture which was introduced with the Pentium, right, the few set of combinations, right, the instruction combinations which we can execute parallel, right. So there was a restriction limitation with the first Pentium model, but then later on the superscalar organization is increased with the Pentium. Now, here the point will come in your mind that what if what architectural modifications are done in the processor, right, to support this superscalar architecture. Now, everyone is aware about to execute the instruction what all features or what all resources are required. So we need the execution unit, right? The separate execution unit we need the separate registers for it, bro. Then we need the separate ALU for it, bro. So ALU is a part of your execution unit. So ultimately, multiple ALUs are introduced. Getting this? So here you can easily handle, right? So there are with the Pentium processor, you can see if you explore more about Pentium processor, you can see that U and V pipelines are there, right? So here ultimately you can see Pentium Pro, which is having increased superscalar organization. And then aggressive register renaming is there. Then branch prediction is one of the technique which is helpful to improve the performance. Then data flow analysis, speculative execution, these all features were introduced with the Pentium Pro. Then Pentium 2 MMX technology was introduced, multimedia which supports processing of all multimedia files, right? The multimedia files, so graphics, video, and audio processing was handled with the Pentium 2. Then Pentium 3, the additional floating point instructions for 3D graphics were introduced. Then Pentium 4, note Arabic rather than Roman numerals. So here this additional point was introduced with the Pentium 4. Then further it is supporting floating point and multimedia enhancement features were introduced. And then it comes to the core processors. So here the first x86 dual core processor was introduced, right? So when you talk about the core, recently we have our mobile processors and all with multi-core processors, right, in mobile phones as well. So with this core, this is the first model in which multiple core were two core were introduced, bro. So here these core are independent, we can say independent processing unit is present on the chip, right? And parallelly, both cores can execute. So whatever the threads which were possible, right, but to handle by a single core, that can be handled, by these two cores, right? So here, if one core can execute two threads, then ultimately two dual core can handle four threads, right? So here you can easily understand that we can use the superscalar architecture more powerfully from these core microprocessors of Intel, right? Then Core 2 is one of the model which was introduced, and this is the first microprocessor with a 64-bit architecture. Now, as we have already discussed, 64-bit architecture means the processor ALU is capable of handling 64-bit numbers. So ultimately, these all processors are basically now whatever the recent microprocessors which we are using in our personal computers, all are with 64-bit architectures, right? Then Core 2 got this another microprocessor was introduced. It is having basically four processors on chip. Getting this? So four processors on a single chip. So this slide contains up to this particular Core 2 called microprocessor. And if you go through the recent microprocessors which are there in the market, you can see i5, i7, Core i9. These are basically the different architectures which are introduced by Intel. Bro, so here you can easily decide, right, based on the capacity of that particular architecture, which microprocessor we need to use for particular programming, right? So here there are a few
Hello,
lines
sir.
about the yes.
Sorry to interrupt, but I had doubt that, sir, in core processing, when the core introduced, so it introduced the parallel computing. So what was the difference between the previous Pentium parallel programming and the core programming?
Basically, if you just check the Pentium processors, there only the pipeline structured were used, right? The ALU kind of. So there are shared resources were available with the earlier processors, but with the core, dedicated resources are given for a particular core. So whatever the dedicated resources means, when we talk about the core, it requires ALU, it requires the general purpose registers, it requires the cache, right? So that is a single core requirement. So with the core architecture, those all shared resources are removed. So by this, what we can say is that the performance will be more improved, right?
Okay, so independently it will work on core.
Yes, purely. Like there are basically different techniques which hyper-threading and all, so many things are there with the Intel architecture. But with the core, the independent resources were given so that it can work, it can execute parallelly with the other cores. All right.
Yes, sir. Okay.
Yeah. Then there are a few points associated to the architecture. So x86 architecture dominant outside the embedded systems. Then organization and technology change dramatically. So Intel is dominating the complete market in microprocessors, but ARM is also there. But still, Intel is in general market coverage is much higher than other microprocessors. Instruction set architecture evolved with backward compatibility. This is a very interesting one. Backward compatibility is provided by the Intel range of all these microprocessors. So here, with this particular compatibility feature, we can execute the earlier codes on recent microprocessors as well. Right. Then here, approximately one instruction per month added. So here you can see the instruction size is quite good in Intel. Around 500 instructions are available, and the line is given, like you can refer to the resources which is available on Intel. Right. So this is just a brief history of Intel microprocessor. And if we exam point of view, if I tell you about this particular point, mainly the comparison of different microprocessors will be asked, right? So as a question, compare different microprocessors, or compare the in terms of different features, you have to compare those microprocessors. Right, so you need not have to go up to the core to quad microprocessor. Up to Pentium you can compare, right? So for 4 to 6 marks, that question may be asked, right? Now let's go ahead with the next topic. So here we'll cover features of 80386. As per the syllabus, we will be having the next topic after brief history. We'll be having features and architecture. So today we'll cover about the features of 80386. Right. Now, as we discussed earlier, 80386 is basically a 32-bit microprocessor. Right. Now, when you talk about the 32-bit microprocessor, that indicates that is the maximum number of bits which can be handled by your microprocessor, as a single operand. So, what minimum size of data that can be handled? So, as a arithmetic operations, for arithmetic and logical operation, it make use of minimum 8 bit. So, 8 bit, 16 bit, and 32-bit data types are handled by your 80386. Right. So this is a very important point. When we say our microprocessor is 32-bit, it doesn't mean that only 32-bit operands can be handled, right? So it can handle 8-bit, 16-bit, and 32-bit, and a few bit manipulation instructions, right? So Boolean operations can be used, right, for a single bit operations. Then it is having 8 general purpose registers, right? 32-bit registers. As I told you in earlier discussion, Whenever we talk about the type of your processor, it's 32-bit microprocessor. So the first point that we highlighted is its ALU size. So that handles 32-bit data. Second point that I highlighted is the register size, right? Whatever the general purpose registers are there, those are of 32-bit. Now here I'm emphasizing on the keyword that general purpose, bro, because in addition to general purpose, there are some system registers which are having different sizes. So we'll talk later on. But the general purpose registers which stores the intermediate result or the operands, right? So to hold those results or to provide the data to ALU, we need these 32-bit registers. Then very large address space is it is having. There is a direct relation of this address bus and the addressable space, physical address space. So you can note down data bus is of 16-bit. Data bus is of 32-bit. Address bus is of 32-bit. Both are 32-bit in 80386. All right. So external data bus is 32-bit. External address bus is also 32-bit. So with the 32-bit address bus, we can easily calculate 2 raised to 32, which is 4 GB of physical memory. Right. Now, this 4 GB of physical memory with the virtual memory concept, which is introduced with this particular processor, we can extend this particular memory up to 64 terabyte. Right. So here, 64 terabyte virtual memory we can have. Right. Then that calculation and all we'll discuss when we talk about memory organization of 386. Then segmentation is made, right? All these memories which we are talking about. So this complete memory, which is possible for microprocessor to access, which is divided in different segments, and each segment can have size up to 4 gigabytes. So one segment can have a size of 4 gigabytes. So physical memory is 4 gigabyte, but in virtual memory, we can extend it up to 64 terabyte, and ultimately, whatever the segments which we are generating, we can have size of 4 gigabyte for each segment, right? Then it is having integrated memory management unit. So virtual memory support is there. Optional on-chip paging is there, 4 level of protection is there, and fully compatible with 80286 is there. So when we discuss about the advanced features, memory management. So memory management, it supports virtual memory, right? Then on-chip paging is there, which is optional. So programmer can enable or disable this paging. Then protection is there. So 4 levels of protection is there. Then which is compatible with 80286. Object code compatible with all 8086 family microprocessors. So whatever the earlier microprocessor object codes are there, those can be executed with this particular microprocessor. So whatever the binary codes which are generated with the earlier family members, those are basically can be executed with this microprocessor. Then virtual 86 is the additional mode, right? Which yesterday I told you. Your microprocessor, this 80386, it runs into two basic mode, right? The real mode and protected mode. And this virtual 86 mode is also there, which is basically used to execute 8086 software in a protected and paged system. Right. So when we discuss about the virtual mode, we will talk in detail. But at this point, I will highlight on why it was required to introduce this virtual mode with 80386. As we discussed, 8086 code it is required to execute, right, in the recent microprocessor. So to execute those 8086, which is having 16-bit architecture. 8086 is basically having 16-bit architecture and having 1 MB, 1 megabyte of memory space. So to make use of this protection mechanism and whatever multitasking feature of 80386, how these 8086 can be executed. So to enable execution of these 8086 codes, this virtual 86 mode is basically enabled, made available with the 80386. So to execute this 8086 code, it is required to switch out from the protected mode next to the virtual mode. So in virtual mode, it will be transferred. The mode will be changed, and in that environment, it creates the V86 machine, right? So virtual 86 machine will be created, and it will make existing memory. Out of that existing memory, it make available your 1 MB space, memory space, and in that environment, it can execute the code. The virtualization technology that I think many of you are aware about, right? In computer systems, recent the VMware and all those processes or those applications are used. So in that, what is happening? It is making use of existing system, right? The infrastructure is same, but it is enabling us to execute multiple operating systems, right, under the control of host operating system. Getting me? So like that, in protected mode, we can have different virtual machines, right? Virtual 86 machines, right? The applications we can run. Then next one is debugging support, hardware debugging support. So I think all of you are aware about debugging your codes, right? So to enable debugging of code, there is a separate there are separate registers which are available and which supports this debugging. Now, whatever the debuggers which are designed, those are basically using these debug registers. Then optimized for system performance. So to improve the system performance, there are additional things which were introduced with 80386. So pipeline instruction execution is introduced. Then on-chip address translation caches are used. The clock frequency which is used is 20, 25, and 33 megahertz of clock frequency. And the 40, 50, and 66 megabytes per second bus bandwidth is there. Now this bus bandwidth is associated to the external data transfer, right? And the operating frequency of your microprocessor is 20, 25, and 33. So whenever we will discuss about the external clock that we are applying, it will be of CLK2, right? So it will be CLK2. 1 second. Huh? Then sorry for interruption. Then numeric support via Intel 387 DX, that math coprocessor. So as I told you, in evolution of 80 Intel microprocessor, 80386 was the last microprocessor to which external coprocessor was connected. So this 80387 was the coprocessor which is connected externally to the main processor. So, and these coprocessors are very specifically designed to handle the floating point numbers. So, for 80386, the compatible coprocessor is 80387, right? So, for every microprocessor before 486, right, there is a separate version of coprocessor that was introduced. Then so complete system development support was there, which is basically used to design the system programs and all. So C, PL/M, assembler system generation tools, these all tools are basically supported by your microprocessor. Then different debuggers are also listed. So it is a P-scope and IC386. These are the debuggers, right? So these all softwares and debuggers were used along with this 386 microprocessor. Then high-speed CHMOS for technologies used to fabricate this microprocessor. 132-pin grid array packaging was used. That is one option, and then other option is 132-pin plastic or flat packaging. Two type of packaging was available with the 386. So if possible, we can see that image as well. So these all are the features, right, of 80386. Now let's cover the next point of this particular presentation. That is different modes, right? Processing modes. I was talking about the different modes. So basically, your processor starts whenever we power on the processor. It starts in the real mode, right? It starts in the real mode, and after real mode, it is required to switch over to the protected mode. Right? It is required to switch over to the protected mode. So ultimately, protected mode is basically the natural 32-bit environment in which all instructions and features are available. So here we can easily see this is the mode, protected mode, in which you can make use of all features, right? So to maximize the use of resources available with 80386, we need to switch over to the protected mode, right? So real mode is the basically mode in which your process starts immediately after the reset, and in real mode, 80386 appears to programmers as a fast 8086. So ultimately, what happens in a real mode? It is only possible to execute 8086 programs, right? And some 80386 instructions, which are possible to execute with the 8086 environment, right? But as hardware resources are of 80386, so in real mode, we can only execute 8086. So it is treated as a faster 8086 machine with the real mode. And after that, it is required to make necessary initializations to switch over from real mode to protected mode. So that we'll discuss in coming sessions. Right. Then the third mode is a virtual 8086 mode. So it is a V86 mode. As I told you, it is a mode which is executed or which is run under the control of protected mode. So it is dynamically switched over to this particular mode, and that is required whenever it is required to execute 8086 program. So it is a dynamic mode. Processor can repeatedly and rapidly switch between V86 mode and the protected mode. And CPU enters V86 mode from protected mode to execute your 8086 program. So whenever you have 8086 program to execute under the protected mode environment, it is mandatory to switch over to V86 mode, right? Then processor can enter and leave V86 mode. So from protected mode, when it returns back to the protected mode, it can execute its 80386 program, right? So switching between the 8086 V86 and protected mode, it is not really going to make a change with the basic mode of your operation. So after returning back to the protected mode, it can execute your 80386 programs, right? Now, to switch over from real mode to protected mode, I told you that there are several initializations which are required. Whereas, no, so many things are there, right? So table initializations are required, then stack initializations are there, which is to be initialized. But to switch over to virtual mode, there are very few things which need to be initialized. So that we'll discuss when we talk about the switching to or initialization process and all, right? This is just an introduction part to your memory organization and segmentation, right? So here in this slide, as I told you, the memory organization, which is basically associated, right? The addressable memory is mainly associated with the number of bits in address bus. So when you talk about the address bus is of 32-bit, and as we discussed, 32-bit address bus, with the 32-bit address bus, we can have addressable memory up to 4 GB, and the range of address which is possible is from 0 to 2 raised to 32 minus 1. Bro, so here you can easily write the address, right? All zeros and up to FFFF. So whatever the 32-bit 1111 is there, so that you can easily write that particular address, right? So here 8-digit FFF you can write as a last address, right? It is 8-digit. So ultimately, that is the complete range of physical memory. Now, 80386 programs are independent of physical address space. So these programs written without knowledge of how much physical memory is available. Here, this is a very interesting feature, right? Virtual memory concept was introduced. Here, it is possible to execute the large programs with the less memory, less physical memory. So here, as a programmer, we need not have to worry about the physical memory chips which are available, right? So this is what the virtual memory concept which was introduced with 80386. So how it is happening and all that virtualization method, address translation mechanism that we'll discuss in coming sessions. So here you can see the 4 GB was the addressable memory, means what? 4 GB memory chip we can interface. But now recently, like hardly few years back, only 4 GB chips were made available in the market, general market. So because of the manufacturing cost of these memory chips and earlier you can see the 128 MB of 512 MB of memory chips were there in our computers, right? Then later on 1 GB, then 2 GB, 4 GB. Now people are having 8, 16 GB of memory chip and higher memory chips, right? So with the help of virtual memory concept, we can easily make use of less physical memory. So without knowledge of how much physical memory is available, right? You can easily execute the program with the higher memory size. So it means that part of memory, where part of your program will be only taken into the physical memory space, and other part will be kept on the virtual memory space. Getting this? So here the paging and all that we'll see later on, but at this stage you can easily understand that with the virtual memory how we can increase the addressable space. The model of memory organization seen by application programmer is determined by system software designer. So ultimately, whatever the operating systems are there, those are designed in such a way that they will handle these all memory references, right? The model of memory organization is there. Different memory models are there. One is a flat memory address space is there, and segment address space is there. Basically, this flat address space and segmented address space, two memory organization models are there with the 80386. So if we select the flat address space means what? There is a single array of 4 GB memory. So here with the flat address space, that is again decided by the programmer, right? We can select the flat memory model. So with the flat memory model, up to 4 GB only we can have memory space. So with the flat memory model, wherever we require less than 4 GB of memory space, we can select the flat memory model. But in a segmented address space, we can have multiple segments, right? We can have multiple segments. So here, how many segments are possible? That calculation we'll discuss when we talk about the different tables, right? The descriptor tables, global descriptor and local descriptor. So up to 16,383 segments are possible, and each segment will be of up to 4 GB of space. So here you can easily calculate if one segment size is 4 GB, so how much virtual address space we can have in the segmented address space. So So physically, up to 4 GB of memory is possible, right? The physical chip that we can have. But with the memory organization, right, the virtual memory concept, with different descriptor tables, we can have up to 16,383. So it is approximately equals to 16K. Bro, so 16K. So 16K into 4 GB. Right, 16K into 4 GB. So how much it will be? Can anyone calculate 16K into 4G? 4 GB. How much it will be? $16K into 4 GB. After giga, there is a terabyte. So it is 64 terabyte. So what in earlier discussion, as I told you, the virtual memory space up to 64 terabyte is possible. So this is because of this segmented address space, right? And in both the models, we can implement the protection model, right? The ring of protection, right? So this is how these features of microprocessor 80386 are used, right? Now let's conclude this particular session.